Hey, I thought I'd give a little update on the ECU progress that I've been working on. So this is the GUI. So you can see from here, this is where you set up all the inputs. So you got a map sensor, a crank sensor, and cam sensor, and this is where you set up the pins and kind of what translation you're going to be using. This is set up for a 24x LS engine right now. You can add more inputs to it. So from here you can select what type of input. It's an analog pin, whether you're trying to read duty cycle or frequency, kind of any of these things. And then from there you can give it a lookup table, either a polynomial function with a variable number of degrees. So that's all computable, or a lookup table, and then that's just your standard. You get your raw input, and this is 0 to 3.3 volts. And then down here you can input your lookup table function. From here you select kind of what kind of measurement the value is, whether it's pressure, speed, kind of whatever that input is. You can see like for map, so it's pressure. You can see the lookup table is just two values. It's kind of standard map sensor for a GM vehicle. Then you get your engine tab that's got you select what sensors you got. So this kind of helps you if you have multiple map sensors or crank sensors or anything like that. This lets you set up those sensors. There's also cylinder air temperature. So right now this is just looking at a static value, but you could set this to your intake air temperature or your engine coolant temperature, or add in a calculation between the two to kind of come to what the cylinder air temperatures are coming in. Over to the engine calculation, you got your cylinder air mass calculation. So you can see right here you have speed density. I'll be adding alpha N and things like that later on. Right now it's just speed density. Then you got your volumetric efficiency. So we set this up as a 2-axis table. This is also be a lookup table or just a static value, kind of whatever you're wanting to set it up as. And you can see if I open this table, it opens up the table. I need to zoom out real quick. There we go. So this is all editable as far as what values you're wanting to go for the min and max RPM, min and max manifold air pressure, and you can select different inputs too to look at. You can see right now it's just the whole table is 80%. So one of the things I need to work on is kind of the display value. So these should be percentages instead of the raw value, which is just a 0.8. So I'll be adding that in the future. That kind of completes the engine tab. And in our fuel tab, you have things like your air-fuel ratio, whether the injectors are enabled or not. So this, I don't have it here right now, but this is where the calculation will go for rev limiter if you're going to want to do that fuel cut. Right now it's just set to a static enabled value. Then you have your injector pulse width, calculation. So this is just a dead time. You'll be able to select different calculations here as I come up with them. So this just kind of has your injector flow rate and the dead time for its open. Then the last kind of parameter you have for injector properties is the ending position, so where you want to stop injecting fuel. This is usually happens kind of right before the valve closes, or slightly after if you're wanting to put a little fuel on the back of the valves. But that's all tunable. Right now it's just a static value, but you can change this to a lookup table and select different RPMs. I want to end at different positions. So that's something you can do. You can also make this a 2-axis table. So this is kind of the the power of my tool, or the power of my ECU, is that you can kind of set up whatever calculations you want for any of these parameters. Then on the right here, you just have all your injector outputs. Right now they're all set up on the same pin, but you can set up what pin to output on, the top dead center value for each one of the injectors, whether the output is inverted, and whether you're have a high Z, so you're just wanting to do an open drain output. Then the ignition tab, you got some similar things. So your ignition enable, so this is where a rev limiter would go. Ignition advance is a 2-axis table, so if I open this, currently it's just all 10 degrees. I'll be updating this for the actual car later on. Then you have your ignition dwell. So this is another thing kind of that I want to be able to have a drop down here, so I can change this to milliseconds or anything like that and have it automatically update. But for now, I'm just kind of working with what I got because I want to get the car started. You can see the ignition dwell here, 3 milliseconds, and then this ignition dwell deviation. So this is, if when you start dwelling, it's about 3 milliseconds in advance of when you want to actually spark. So within that 3 milliseconds, the engine could speed up or slow down, or the ignition timing could change based on a different manifold air pressure or the changing RPM. And so this just tells you how much you can go forward or backwards on that dwell amount in order to kind of achieve that. Just kind of fine-tuning the ignition event. So you can see right now it's static, but you can make this a lookup table or 2-axis table, just like with everything else. On the right, you can see the ignition outputs, pretty much the same as the injector outputs. These are actually set up, so the different pins they're connected to and whether they're inverted. The other thing I want to add is make this a drop down, so you can select which pin, and then kind of have a picture with an overlay of where that actual pin is. So that kind of concludes the GUI tour. Something I've been working on recently is the ignition code. I just kind of updated this to make it a little more robust. Basically, there's three different scenarios where you're going to be adjusting the dwell and ignition events. So when you're dwelling, you're going to kind of adjust the end of that ignition event, and if you're not dwelling, then you're going to want to make sure that you're doing every ignition event, and you're not skipping one due to a changing ignition timing or a change in the engine RPM that kind of overlaps the dwell and makes it so where it doesn't happen. And then if we haven't dwelled in a while, then we're just going to make sure that we can dwell, or make sure that what we're scheduling is ahead of us and not behind us. So I've got this set up on the bench. So you can see this is the STM32F401C board, the black pill, and then I just have a STM32F103 board over here acting as a cam and crank sensor emulator. So you can see the LEDs blinking, and so that's actually blinking from the time scheduler that I created. And then if we come over to the scope, you can see that this is the yellow is the cam sensor. So that happens once every 360 degrees. It changes. So for a full 720 degrees. So you can see right now we've actually got sequential ignition timing going. And so you can see that little blip with the dwell and everything. And if I zoom in on here, you can see that it's pretty stable. Zoom back out here. The other nice thing is, you know, if you lose the cam sensor, so I'm just going to pull that out, like you lost your cam sensor, then you no longer are able to do sequential. So you can see that is happening up here. We're doing a wasted spark. So it's kind of some fault. So if I plug this back in, you can see we go back to sequential timing. And then if I just come over here and disconnect the crank sensor, connect this back. Sorry, my probe came off here. Kind of difficult to do this one-handed. See, we're triggering. If I take the crank sensor off, you can see we're still triggering based off only the cam sensor. So we're able to handle a fault with either the crank or the cam sensor and still operate. I guess I could also pull open the no, that's actually going to be difficult to pull open the fuel vents, so I can do that here. So all the fuel vents are happening on the same pin right now, but you can see that that's pulsing an injector. So if this was like working on a throttle body injection or something like that, that would work good for this. So there's all 8 ignition and injector outputs are all operating off of the single timer, and we're getting good timing events. There seems to be no adverse effects of having the schedule there versus just using the raw timers that are on there. And the benefit is you free up those other timers to do other things like PWM inputs or outputs. Yeah, so that's what I've got done on kind of the ECU project so far. This is kind of one of my old projects over here. This is one of my newer boards. I'm actually in the process of redesigning it. I know I'm kind of stuck in the refactor loop. I haven't even built this board yet, but I'm going to build a little bit simpler one. I actually can't get this IC anymore due to the silicon shortage, but the next version of this is going to basically have all the driver ICs over here, and then this part over here will just kind of be a perf board area where you can either solder on one of these blue pills, or I'll also make kind of a custom card that just kind of sits on here and solders to all of the inputs and outputs. So this has all of your injector and ignition inputs and outputs, and your analog inputs and op amps and things for buffering that. You got your power over here for conditioning your power, a CAN sensor there. So if I pull out what this all goes in. It goes in these boxes, so you can see this. I got the footprint of this pretty much exactly right to fit into here. I can just do it. It's a nice snug fit. So that footprint is all good, and then this metal backplate here, and then there's a connector that comes with this. So there's a 50-pin connector, and I got the footprint of this right. I actually adjusted it after I received this, since I was able to kind of figure out that it was a little too snug. It was kind of difficult to get this connector in there, but I've got the footprint updated, so Then the next revision, this will be easy to put in here. But that basically goes there. This goes on top. So yeah, it'll be a nice looking ECU module all contained in there. Comes with a nice connector, all the pins. I think these boxes are only like 15 bucks on AliExpress. So yeah, stay tuned. I'm gonna try and get the new hardware design finished up and sent off to get the PCBs made, and then pulled back here, and I'll assemble them here with my soldering iron and everything, and then I'll try them out on the card. Yeah, so I'm pretty excited to finally have this into a kind of usable state. I still got some more work to do on the GUI, like logging and just some creature comfort things. Let me know if you guys have any questions or want me to go over anything else in more detail. The source code can be found on GitHub. I'll put a link in the description. Also, once I get this board kind of finalized, I'll release the schematics and the board files for those as well if you want to get yours. If you want to make one yourself. Thanks for watching.